time for some e-learning with Miss Atkins. E-learning with Miss Atkins. E-learning with the puppy. E-learning with Miss Atkins. Yeah. What's up, scholars? Today we get to talk about trig. It is super famous. You've probably heard of it. It is using Greek words, trigono for triangle, meter meaning measure. We are measuring some stuff about triangles using some ratios. Now, we use the Greek word trigonometry, but the idea surfaced all over the world, in the Near East, in India, in China, not only in Greek. So, trig's been around for a super long time. And it's ways that we measure stuff about triangles, specifically right triangles. So let's draw ourselves a picture of a right triangle, label some sides and angles, and then talk about these really special ratios. Okay, so we got this right triangle, triangle ABC, and we have labeled its vertices ABC. Obviously, that's why it's triangle ABC, and it's a right triangle. And then we've labeled the sides opposite those vertices using the lowercase letter. So the side opposite angle A is little a. The side opposite angle B is little b. And the side opposite angle C, our right angle, is our hypotenuse, side C. Sweet. So there are 6 trig ratios. We're only going to talk about 3 because these are the basic 3, and then the other 3 are actually built off of those original 3, kind of like the primary colors. These are like the primary trig ratios. They are sine, cosine, and tangent. Sine, cosine, and tangent. Okay, and again, they are ratios. So, we define sine as the ratio of the opposite side over the hypotenuse. Now, what in the world does that mean? So we're going to look just at angle A for all of these to talk about these 3 ratios. So the sine of angle A, which we abbreviate SIN, the sine of angle A is the ratio of the opposite side to A over the hypotenuse. So in our example, the sine of angle A, what's the opposite side of A? Well, it's little a. Over the hypotenuse, that's little c. A over c. Okay, cosine is the relationship of the adjacent side to that angle over the hypotenuse. So let's find the cosine, which we abbreviate COS, of angle A is the adjacent over the hypotenuse. So let's look at angle A. Who is the adjacent side to angle A? Adjacent means next to. Well, there are 2 sides that are next to angle A, the hypotenuse and side B, but we don't want to use the hypotenuse as the adjacent side. That's going to stay as the hypotenuse. So the adjacent side must be side B over the hypotenuse C. We have sine of A is the opposite side over the hypotenuse. Adjacent of angle A is cosine is the adjacent side over the hypotenuse. And then tangent, which we abbreviate as TAN. The tangent of angle A is the opposite side over the adjacent side. So the opposite side to angle A is A, little a. The adjacent side to angle A is B. So those are our 3 trig ratios. So why does this make any sense? Well, whatever angle A is, since this is a right triangle, is going to have fixed relationships. So if this angle is 30 degrees, the relationship between its opposite side and hypotenuse will always be the same. Same thing with the cosine and the tangent. So we can use this information to find out other stuff about the triangle. We could maybe find one of its missing sides or missing angles. And we can use this information to help us solve problems in the real world. Now, I usually see trig show up in physics. Let's find a picture here. Yeah, something like this guy over here. So when you're moving stuff on inclined planes, that happens a lot in physics. Or with solenoids, it looks like. This is some good stuff. Here's also some pictures of the sine function. It's a continuous function, will go on forever, and then cosine is 90 degrees out of phase, meaning if you took this sine wave and shifted it back, you'd get the cosine wave. Tangent has a funkier picture. We don't need to worry about that just yet, but that's where you see a lot of trig show up, as in physics. Okay, there's a mnemonic to help you remember these ratios called SOHCAHTOA. 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 Sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. All right, let's talk about the trig ratios for our two types of special right triangles, namely a 45-45-90 and a 30-60-90. Let's do our 45-45-90 triangle first. So here's my 45-45-90 triangle. And we remember from our discussion previously about our special right triangles that the side lengths in this 45-45-90 triangle have specific ratios, namely the legs are always the same number, and the hypotenuse is that number times the square root of 2. So, for this example, we're going to pick the easiest number we possibly can for x being 1. That makes the side lengths of our triangle 1, 1, square root of 2. So now let's find the sine, cosine, and tangent of this angle, 45 degrees right here. The sine of 45 degrees is sine is opposite over hypotenuse. Who's opposite 45 degrees? 1 over the hypotenuse, square root of 2. Opposite is 1 over square root of 2. Now we should rationalize the denominator, meaning we multiply by the square root of 2 over the square root of 2. And when we do that, we get the sine of 45 degrees is square root of 2 over 2. Now how about the cosine of 45 degrees? Well, the cosine is adjacent over hypotenuse. So who's the adjacent side to the 45 degrees? Remember, we're not going to use the hypotenuse as the adjacent side, so we're going to use the 1 here as the adjacent side. So that's also 1 over the square root of 2, which we know rationalizes to the square root of 2 over 2. And then how about the tangent of 45 degrees? Well, tangent is opposite over adjacent. The opposite side to 45 degrees is 1 over 1. 1 over 1 is 1. And this will be the relationship regardless of what these side lengths are. For every 45-45-90 triangle, this is going to be what you get when you find the three trig ratios. Okay, that was our 45-45-90. Now let's talk about the 30-60-90 triangle. So here's our 30-60-90 triangle. We remember the special relationship these sides are in from our previous lesson. We know the side across from the 30-degree angle is some number. The side across from the 60-degree angle is that number times the square root of 3. And we know the hypotenuse is twice that original number across from the 30-degree angle. So let's do the same thing we did last time. Let's pick 1 for x to get the simplest version of these side lengths. So now we've got a triangle whose side lengths are 1, square root of 3, and 2. So let's find the sine, cosine, and tangent of that 30-degree angle. Sine of 30 degrees is going to be the opposite over the hypotenuse, so 1 over 2. The sine, whoops, nope, now I want the cosine. The cosine of that 30-degree angle. Cosine is the adjacent over hypotenuse. Right, so our side adjacent, we're not using the hypotenuse, we're going to be the square root of 3 over 2. And the tangent of 30 degrees is the opposite over the adjacent. Opposite of 30 is 1. Adjacent to 30 is square root of 3. So we have 1 over the square root of 3. I'm going to rationalize our denominator there. And we get the square root of 3 over 3. Cool. Since these are such popular triangles, you'll see these ratios show up a lot. This is obviously the fractional form. You could convert these to decimal form if you want to. So if you want them, here are the 4-digit decimal approximations, which you totally can find in your calculator because you're a bunch of geniuses. All right, so I said most often shows up in physics. We're going to use another application where we can figure out how tall something is using an angle of elevation. All right, angle of elevation. Let's say you are checking out this beautiful tree. And you wonder to yourself, how tall is that tree? Well, I know some trig, so I can figure out how tall that tree is. Let's say you walk away from the tree and you look up at it. There's your eyes, okay? So here's a line, parallel to the ground at your eye length, and you look up to the top of the tree. Oh, it's totally working. Great. Yes. And we've got a right triangle here in space. Again, you looked up at the tree. So your eyes made what is called this angle of elevation, right? I'm going to use theta. Theta. That'll be our angle measure. Theta. Angle measure. Now you can use theta for any angle. It doesn't have to be an angle of elevation. But in this case, theta is our angle of elevation. So we're wondering about how tall this tree is. Okay, so we walked away from the tree. My line really should go like this, shouldn't it? Shouldn't be in the middle of the tree. We walked from the edge of the tree, of course. Okay, let's say we know how long we walked. We know what this angle is. We can figure out the distance from our sight line here and then add our body and figure out how tall that tree is. That's pretty cool. So let's add some numbers in there. Let's say that you're 6 feet tall. Okay. And you walked, just making all this totally up. You walked 30 feet away from the tree. And you had this inclinometer, which measures angles. So when you looked up at the top of the tree, you made a 37-degree angle with your eyes. So you went 37 degrees. So we could figure out the length of this side of the right triangle here. If we found out that length and added 6 feet to it, then we'd know how tall this tree was. Now, what ratio are we going to use here to figure this out? Well, we redraw the triangle. So that's all we're looking at. We know that side is 30. We know this is 37 degrees. we're trying to figure out this side over here, which relationship uses the side that's opposite 37 degrees and the side that's adjacent to 37 degrees. I don't know, let me check my SOHCAHTOA. I'm looking for opposite and adjacent, so I must be looking for tangent. Okay, so we want the tangent of 37 degrees. We're just setting it up. The tangent is the opposite side over the adjacent side. Opposite side is x. Adjacent side is 30. We're going to use this to solve for x. Figure out how tall that chunk of the triangle is, and then we'll add our 6 feet to it. And we'll know how tall the tree is. Okay, so how are we going to find the tangent of 30 degrees? If we go to your calculator on your phone, yep, calculator on your phone, maybe your calculator looks like this. We go over, we press the tangent button. You got to make sure it's in degree mode. Your other option is radian mode. We're not going to use that right now. We're going to use degrees because we measured our angle in degrees, right? 37 degrees. So the tangent of 37 is 0.753. Let's round to the, let's give ourselves 4 digits here. So 0.7536. 0.7536 is the tangent of 30 degrees. 0.7536 is x over 30. Okay, again, we're solving for this side of the right triangle. So we're solving for x, so we'll multiply both sides by 30. And equals times 30 is x equals 22.6 feet. So this side of the right triangle is 22.6 feet, so the total height is 22.6, right, plus how tall we are is our 6 feet. So this tree is 28.6 feet tall. Pretty cool, huh? Yeah, it's definitely very cool. Alright, scholars, that concludes today's video. Bean, say bye. Love you. Alright, this is the time for hustlers, so keep on that hustle, scholars. Love you. See you next time.